Hello everyone, welcome back to another kinetic tutoring episode. Today we're taking a look at another FRQ um from the one from an AP Physics C Mechanics exam. So let's get straight into it. The cart shown above, sorry, I don't have the image of the cart pulled up. Let me just open it right here. Here it is. Here's the image of the cart. It rolls down a hill and then it goes into a spring. So let's get back to the problem. The cart shown above is made of mass m and 4 solid rubber tires, each of mass m/4 and radius r. Each tire may be considered to be a disc. A disc has a rotational inertia of 1/2 ml squared, where m is the mass of it, L is the radius. The cart is released from rest and rolls without slipping from the top of an inclined plane of a height h. Express all algebraic answers in terms of the given quantities and fundamental constants. Part A asks us to determine the rotational inertia of all 4 tires. So here we're given the what's it called? The inertia of 1 tire, and we know that the mass is m/4. So we get that 1/2 m/4 r squared, which will give us 1/8 mr squared. This is the inertia of 1 tire times 4 will give you the inertia of all 4, so 1/2 mr squared is the inertia of all 4 tires. Let me just write that out here, 1/2 mr squared. B says determine the speed of the car when it reaches the bottom of the incline. So we know we have mgh, or sorry, rather, the block is mass m and the 4 tires combined together are also mass m, so the mass of the entire thing will be mass of 2m. 2 mgh equals 1/2 mv squared, where m is the mass of the entire system, so it'll just be mv squared plus 1/2 inertia omega squared. So from here we get 2 mgh equals mv squared plus 1/2 mr squared. And we know that omega is just velocity over radius. So we get v squared over r squared. These r squareds cancel, and the mass and everything cancels. So we get 2gh is equal to v squared plus 1/4 v squared. So 2gh is equal to 5/4 v squared and therefore 8/5 gh is equal to v squared, so the square root of 8/5 gh is going to be equal to our velocity. So there you go, there you have it. Square root of 8gh/5 will be your velocity at the bottom of the plane. After rolling down the incline and across the horizontal surface, the cart collides with the bumper of negligible mass attached to an ideal spring, which has a spring constant k. Determine the distance xm the spring is compressed before the cart and bumper come to rest. Alright, so we know that we have our 1/2 mv squared, both of our kinetic energies. And at the end, we're just going to have potential energy, spring potential energy, 1/2 kx squared. We can get rid of all of these 1/2, so we get mv squared plus 1/2. And we can simplify this I omega squared. Our inertia is 1/2. Oh, sorry, the m is 2m. 1/2 mr squared v squared over r squared is equal to, oh, we got rid of this 1/2, is equal to kx squared. So here we get 2mv squared plus 1/2 mv squared is equal to kx squared. So we get 5/2 mv squared divided by k is equal to x squared. So the square root of this, but if I write it better, it'll be 5mv squared over 2k. Square root of this will be equal to x. So there you have that. That is the distance before the cart and bumper come to rest. Part D asks us, now assume the bumper has a non-negligible mass. After the collision with the bumper, the spring is compressed to a maximum distance of about 90%, given a reasonable explanation for this decrease. For this reasonable explanation, you can really use any reason for the block to be going slower. For example, the bumper caused more friction, the bumper caused more air resistance, something like that. That's an example you want to use, something, because we know the slower it goes into the spring, the less the spring is compressed. So this bumper would have to cause the cart to slow down and reach a slower maximum speed. So friction or air resistance would be my go-tos. If you have any other comments or concerns, make sure to leave them down below. I hope this helped, and have a great day.